Hello everyone and welcome to today's daily problem. So for this problem, we are going to solve this. A rectangular box with an open top must have a total volume of 25 cubic meters. The length of its base is twice that of its width. Material for the base costs $8 per square meter. Material for the sides costs $5 per meter. Find the total cost of the material for the cheapest box. So this is a standard calculus optimization problem. We can see we have the little diagram here. So we have one side is x length, the other side is 2x length, and the third side is the height h. And so we're going to try and optimize for cost. Now, we know that the cost for a box is going to be each of these sides, including the base added together, multiplied by the cost for that component. So, for instance, we have the base, which is 2x times x times 8. So 8 times 2x times x plus, we're going to have two of these sides, two of the x sides. So x times h times 5. So 2 times 5 times x times h. And then we're going to have two of these sides, so two of the 2x sides. So this is going to be 2 times 5 times x, or times 2 times x times h. And now we're just going to simplify this. So we see that 8 times 2 times x is 16x squared, plus this is going to be 10xh plus 20xh. And so this is going to simplify down to 16x squared plus 30xh. Now, the big question for us is, what is h here, right? We can only optimize in terms of one variable, so we need to figure out what to do with this h term. Now, remember that volume is equal to base times width times height. And since we have the total volume is 25 cubic meters, we know that 25 is going to be equal to 2x times x times h. And so we're going to have 25 is equal to 2x squared h. And so h is going to be equal to 25 over 2x squared. Now we can take this h value here and substitute it into our equation. So we know that we have a cost, or let me do this up here. So cost is equal to 16x squared plus 30x times 25 2x squared. This simplifies down. We get 16x squared plus, we can divide out the 2 from these, so we get 15. X divided by x squared is just x on the numerator, or x in the denominator rather, so we get x down here, and we're going to multiply this by 25. Gives 16x squared plus 375 over x. And now we're going to optimize this. And so doing that, we're going to solve for the first derivative and find where that equals 0. So we have the first derivative of c of x is equal to, this is just a power rule problem, so we drop down the exponent and subtract it by 1. So this is going to become 32x plus, or rather 32x minus 375 over x squared. Now we're going to solve for this when c prime of x equals 0. So if we set c prime of x equal to 0 and then add 375 over x squared to both sides, we will get 32x is equal to 375 over x squared. Multiplying both sides by x squared, these will cancel. and this gives us 32 x cubed is equal to 375. We can divide out 32 from both sides, and this will yield x cubed is equal to 375 over 32. Sorry guys, I'm running out of space here. We will bring this up here to just finish it off. So now we just have to take the cubed root of both sides, and we get x is equal to the cubed root of 375 over 32. Now, normally we would have to take the second derivative and use the second derivative test to determine whether or not this is a minimum, or we would graph this or something like that. But because we have a parabola, right, which is concave up, we know it's concave up because this is a positive term here. We know that it only has one minimum and it has no maximum. So therefore, this must be the minimum. And so this is the value we're looking for. So this is solution 3, and that is the answer to our question. So thank you so much for watching. We will go over another problem tomorrow. See you guys all later.